The star of Betelgeuse, a cosmic event approaching. The star of Betelgeuse, a brilliant, red, enormous creature that lives in the heavens, has long captured the attention of stargazers and cosmologists alike because of its sheer size and brightness. If Betelgeuse were placed where our Sun is, it would expand to the orbit of Jupiter, emphasizing its huge size despite being approximately 642 light-years away. Due to its enormous size, it is potentially one of the most awe-inspiring stars that are readily apparent to the untrained eye. Betelgeuse has displayed odd behavior, including surprising cycles of both brightness and dimming. Numerous researchers indicate that the star is nearing the end of its life. The notable physicist Brian Cox recently stated that Betelgeuse is within striking distance of a major event anticipated within the next 14 days. This event, known as a supernova explosion, will mark the end of Betelgeuse's existence. However, it will provide a surprising opportunity for researchers to focus on one of the most bewildering areas of strength and complexity in the universe. Betelgeuse is one of the supergiants, among the largest and most massive varieties of stars. It has been on the cosmic radar for quite some time, but its recent variations in brightness have sparked hypotheses that it is preparing for a massive explosion. As Betelgeuse reaches its final stage, its own gravity collapses its core, prompting a tremendous blast that releases an immense amount of energy, radiation, and material into space. The upcoming blast from Betelgeuse is expected to be a Type II supernova, a specific type of celestial event that occurs when a massive star's core collapses. This collapse releases neutrinos and radiation, creating a shockwave that destroys the star. The explosion will be so bright that it could be visible without the use of telescopes, possibly even outshining the moon in the night sky for several weeks or months. While such an event would be devastating if it occurred close to Earth, Betelgeuse's distance of approximately 642 light-years means that the blast, though visible and dramatic, poses no danger to life on our planet. This cosmic event promises to reshape how we understand supernovas and other celestial phenomena. A supernova explosion is one of the most significant events in the universe, releasing more energy in a fraction of a second than our Sun will in its entire lifetime. Betelgeuse blast will not only be a stunning cosmic display but also a crucial moment for science. Researchers are eager to witness this event from its earliest moments, using a range of ground-based and space telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST, to capture as much data as possible. When Betelgeuse explodes, it will emit a wide spectrum of radiation, from visible light to gamma rays. One of the key components of the explosion will be the flood of neutrinos, subatomic particles that rarely interact with matter. Remarkably, neutrinos can reach Earth before the explosion's light due to their ability to pass through almost everything undisturbed. Observatories such as Japan's Super-Kamiokande, IceCube, and Kamioka Nucleon Decay Experiment in Antarctica are preparing to detect these neutrinos, providing scientists with an advantage in tracking the explosion's timeline. The blast will also provide significant insight into the formation of heavy elements. When stars explode, they forge and distribute elements like gold, iron, and uranium, materials essential for life. Studying Betelgeuse's explosion will give researchers a clearer view of how these elements are formed and scattered, which is vital for understanding planet formation and universal chemistry. While Betelgeuse's explosion is unlikely to negatively affect Earth, it may interact with our atmosphere and magnetic field in fascinating ways. The burst of energy, particularly in the form of cosmic rays and charged particles, could lead to more intense auroras, expanding the regions where the northern and southern lights are visible. Though these rays might briefly influence satellite communications and some technologies, only minor disruptions are anticipated. Perhaps one of the most amazing aspects of Betelgeuse's explosion is its universal visibility. For a few months, or even longer, it may be the brightest object in the night sky and potentially visible during the day. This event will not only thrill professional astronomers but also ignite interest among amateur stargazers and the general public, rekindling a widespread fascination with space. Scientists have long speculated about Betelgeuse's end, but Brian Cox's recent statement has intensified global preparations. Observatories worldwide are ready to monitor each phase of the explosion. The data gathered could significantly change our understanding of stellar evolution, cosmic explosions, and the distribution of heavy matter in the universe. Because Betelgeuse is relatively close to Earth, it offers a unique opportunity to observe how such an energetic explosion travels through space. By studying the radiation and light as it interacts with the interstellar medium, the gas and dust between stars, cosmologists will gain a better grasp of the size and structure of the universe. The event may also offer rare insight into dark matter, the mysterious substance that makes up about 85% of the universe's mass. Though dark matter neither emits nor absorbs light, observing how light and matter behave around Betelgeuse explosion may provide indirect clues about its nature. This cosmic explosion will also deepen our understanding of the life cycles of stars, particularly how massive stars contribute to creating the elements essential for life. Supernovas play a crucial role in spreading these elements across the universe, forming the building blocks of new stars, planets, and even living organisms. Betelgeuse explosion will not just be a spectacular astronomical event, it will be a turning point for science. By studying it, researchers hope to uncover new insights into the manufacturing and distribution of matter, the evolution of stars, and possibly even the origin of life itself. Beyond the science, Betelgeuse fading light holds symbolic weight. For centuries, humans have looked to the stars for inspiration, guidance, and meaning. The disappearance of one of the most visible stars in Orion's belt will undoubtedly prompt philosophical reflection on the fleeting nature of existence. In some cultures, cosmic events like this have been interpreted as signs of transformation. Betelgeuse explosion may inspire awe and wonder, uniting people around the world in a shared moment of cosmic connection. Modern technology now enables anyone with a camera or telescope to observe and document this celestial phenomenon. This democratization of science ensures that everyone can participate in witnessing and recording the same massive event from their unique vantage points. Ultimately, Betelgeuse explosion is not just a light show, it's a stepping stone for the future of space exploration. The knowledge gained will enhance how we study other stars and support future missions to other planets and systems. As humanity pushes further into the cosmos, understanding stellar life cycles and supernovas will be critical. Additionally, the explosion reignites interest in the search for extraterrestrial life. Supernovas spread essential elements, like carbon and oxygen, that could seed life in distant planetary systems. As Betelgeuse nears its inevitable supernova, astronomers and physicists are also preparing to test several theoretical models that, until now, have remained largely speculative. One such area is the connection between supernovae and gravitational waves, ripples in the fabric of spacetime first predicted by Einstein and detected a century later. Should Betelgeuse core collapse emit detectable gravitational waves, it would mark one of the rare instances where scientists can observe such waves originating from a nearby stellar event, allowing for unprecedented calibration of gravitational wave detectors such as LIGO and Virgo. Additionally, astrophysicists hope to understand the neutron star or black hole that may be left behind in the wake of Betelgeuse explosion. If the star's core is massive enough, it may collapse into a black hole, giving humanity a rare glimpse into the birth of such an object in real time. On the other hand, if it forms a neutron star, it may emit powerful pulses of radio waves detectable across the globe. Either outcome will help refine current theories about the aftermath of supernovae and the transition of massive stars into exotic celestial remnants. There's also an educational and cultural component to this moment. Schools, universities, and science outreach programs are already preparing material to help students and the public understand what's happening in the skies above. Live-streamed observations, interactive simulations, and real-time scientific commentary are expected to flood social media, turning Betelgeuse's final moments into one of the most globally shared cosmic events in history. As the world prepares, astronomers are watching not just for the star's light, but for subtle fluctuations in its infrared and ultraviolet emissions, spectral shifts, and gravitational perturbations. Every twitch of the star's surface, every anomaly in its emissions, could hold critical clues about the timing and dynamics of the impending explosion. And while this event is certainly awe-inspiring, it's also humbling. It reminds us that we are part of a living, breathing cosmos, where stars are born, shine brilliantly, and then die, scattering the raw materials of life in every direction. Betelgeuse's demise will underscore how deeply intertwined our existence is with the stars. In the end, this red giant's collapse will not be an end, but a new beginning, fueling galaxies, forging elements, advancing science, and inspiring generations. The universe, in its mysterious wisdom, continues its cycle. And we, for a brief moment, get to watch it unfold. The mass of the universe and energy remain poorly understood. Some hypothesize that phenomena like the one that Betelgeuse is predicted to produce could hold the key to unlocking some of these mysteries. Supernovae discharge enormous quantities of radiation and energy, and some researchers believe these powerful forces might interact with dark matter in ways we can observe and study. One intriguing hypothesis suggests that dark matter exists as a few interacting particles. WIMPs, weakly interacting massive particles, are among the most studied candidates. If WIMPs exist, their energy interactions, possibly produced by the cosmic Betelgeuse explosion, could provide clues about their nature. Such a discovery would be groundbreaking, potentially offering the first direct evidence of dark matter, a mysterious phenomenon that has puzzled scientists for decades. There is also potential for the Betelgeuse blast to provide insight into the nature of dark energy. Dark energy is the mysterious force accelerating the expansion of the universe. Comprehending its function in cosmic evolution remains one of the most difficult problems in modern physics. The explosion of Betelgeuse could provide indirect evidence of dark energy's influence on the death of stars, like supernovae, which are believed to be shaped by it. Observing the expansion of the universe as Betelgeuse's cosmic explosion propagates throughout space may provide vital information. This could help scientists understand the effects of dark energy on massive events and on the large-scale structure of the universe. As Betelgeuse's cosmic explosion draws near, cosmologists are preparing for one of the most anticipated cosmic events of the century. The blast will offer a unique opportunity to observe the final stages of a massive star, providing insights with implications far beyond our current understanding of stellar life cycles. While scientists anticipate the spectacular display, they are also refining methods to study the effects of such an explosion. One area of focus is the formation of a neutron star, or, conceivably, a massive black hole, in the ruins. The densest part, Betelgeuse's core, left behind by a supernova explosion, may collapse into one of these compact objects. These objects can have more mass than the Sun, packed into a space no larger than a city. If Betelgeuse produces a neutron star, it will provide a one-of-a-kind chance to investigate the behavior of matter under extreme conditions. Neutron stars also produce exceptionally powerful magnetic fields and are sometimes observed emitting regular bursts of light as pulsars. The formation of such a celestial remnant could offer crucial insights into the fundamental physics of extreme gravity and the behavior of matter at incredibly high densities. If Betelgeuse instead collapses into a black hole, it would be another major breakthrough for scientists studying the formation of these enigmatic objects. Black holes, regions of space where gravity is so strong that nothing, not even light, can escape, have fascinated theoretical researchers for decades. Observing the formation of a black hole from a relatively nearby star like Betelgeuse could help refine models of black hole formation and better illuminate their role in the universe. The event may also allow scientists to observe the event horizon, the boundary beyond which nothing can escape, offering further insights into the nature of black holes. Another important aspect is how Betelgeuse's explosion will contribute to our understanding of cosmic rays. These high-energy particles, produced in events like supernovae, can travel vast distances across the universe. While some cosmic rays are detected by Earth-based observatories, others remain difficult to study due to their erratic nature. Betelgeuse's cosmic explosion will produce a massive quantity of high-energy particles, giving researchers a rare chance to study cosmic rays in real time. This could enhance our understanding of how cosmic rays interact with the interstellar medium, and what they might mean for technological advancements and space travel systems on Earth. As the anticipated explosion of Betelgeuse draws closer, the scientific community is preparing for an event that will provide an unparalleled opportunity to study a star's death and its aftermath in real time. While supernovae are not uncommon in the universe, Betelgeuse's proximity to Earth offers a unique chance to observe this cosmic event with unprecedented detail. The data gathered could significantly enhance our understanding of stellar life cycles, how stars are formed, evolve, and how their explosive deaths contribute to larger cosmic ecosystems. The explosion will eject vast amounts of gas and dust into space, which will interact with surrounding materials in the constellation Orion. Researchers will closely watch how these materials spread across the galaxy and interact with existing star systems. These ejected elements, including lighter elements like hydrogen and heavier ones like iron, will be crucial in forming new stars and planetary systems. The material will serve as a cosmic seed, contributing to the ongoing cycle of stellar birth and death. The explosion will also have profound implications for our understanding of space-time and gravity. As the remnants of Betelgeuse form a neutron star or collapse into a black hole, scientists will observe how these dense objects warp space-time in real time. Stars have strong gravitational fields known to bend light and time. If a black hole forms, it will present an opportunity to study the warping of space-time near its event horizon, offering further insights into Einstein's theory of general relativity. The event will also inspire new technological advancements. The vast amount of data collected from the explosion will be analyzed using cutting-edge computational techniques and artificial intelligence. This will not only improve our understanding of the universe but also test the limits of data science, enabling astronomers and physicists to process and interpret unprecedentedly large datasets. Moreover, the impact of Betelgeuse's explosion is expected to extend far beyond the fields of astronomy and astrophysics. The ripple effects of this event may influence a wide range of scientific disciplines, including quantum mechanics, particle physics, and cosmology. For instance, the immense energy output and particle interactions during the supernova could offer rare empirical data, potentially challenging or refining existing theoretical models. Instruments such as the James Webb Space Telescope, the Vera C. Rubin Observatory, and a network of ground-based telescopes around the globe are being calibrated and synchronized to capture the explosion in as much detail as possible. These instruments will work across the electromagnetic spectrum, from radio waves to gamma rays, to ensure no piece of data is missed. This comprehensive observation strategy is critical, as it will allow scientists to construct a detailed timeline of the supernova stages, from the initial shockwave to the dispersal of stellar material. Simultaneously, neutrino detectors and gravitational wave observatories are on high alert. A nearby supernova like Betelgeuse has the potential to produce detectable gravitational waves, ripples in the fabric of spacetime, which could provide entirely new insights into the core collapse mechanism of dying stars. Similarly, a flood of neutrinos, almost massless, elusive particles, might be emitted during the collapse. Detecting these neutrinos would allow scientists to peer directly into the heart of the explosion, bypassing the dense layers of matter that obscure electromagnetic observations. Public interest in the event is also surging. Given Betelgeuse's visibility in the night sky, amateur astronomers and skywatchers alike may be able to witness the explosion with the naked eye, depending on its intensity. It is anticipated that the supernova could rival the brightness of the full moon for several weeks, making it one of the most spectacular astronomical sights in recorded history. Educational institutions and space agencies are preparing to use this event as a unique teaching moment. Curriculums are being updated, public lectures are being scheduled, and citizen science projects are being launched to engage people in real-time scientific observation. This convergence of cutting-edge science and public interest could serve as a powerful catalyst for the next generation of astronomers and physicists. In a broader philosophical sense, the impending explosion of Betelgeuse reminds us of the dynamic and ever-changing nature of the cosmos. Stars, once thought to be eternal, live dramatic lives and die spectacular deaths, often giving rise to new stars, planets, and possibly even life. The death of Betelgeuse will not only enrich the galaxy with the elements required for life but also deepen our understanding of the universe's most fundamental laws. As humanity stands on the brink of observing such a rare cosmic event, the anticipation is not just scientific, it is existential. This explosion offers a fleeting glimpse into the forces that have shaped the universe since its inception and continue to govern its evolution. In watching Betelgeuse die, we are not just observing the end of a star, we are witnessing a chapter in the ongoing story of creation, destruction, and cosmic rebirth.